envrec. Let global object be objrec. Let has property be has own property. Global object n. Let extensible be is it. Binding n d b perform. Objrec initialize binding n.
I just gotta figure out this one little thing, and this part's done. That's all I gotta figure out. It's freaking complicated.
Global function binding concrete method of a global environment record envrec takes arguments n, a string, v, an ECMAScript language value, and e, a boolean, and returns either a normal completion containing unused or a throw completion. It creates and initializes a mutable binding in the associated object environment record and records the bound name in the associated list. If a binding already exists, it is 2, 3, 4, 7, 8, replaced. It performs the following steps when called. Let objrec be envrec. Let global object be objrec. Let existing prop be global object n. If existing prop is undefined or existing prop is true, then a let desc be the property descriptor v. True, true, d. Else a let desc be the property descriptor v. Perform. Define property or throw global object n. Desc. Perform. Set global object n. V. False. If envrec does not contain n, then a append n to envrec. Return unused. 48. ECMA International 2024. Note: global function declarations are always represented as own properties of the global object. If possible, an existing own property is reconfigured to have a standard set of attribute values. Step 7 is equivalent to what calling the initialize binding concrete method would do, and if global object is a proxy will produce the same sequence of proxy trap calls. 1, 1. 5 module environment records. A module environment record is a declarative environment record that is used to represent the outer scope of an ECMAScript module. In addition to normal mutable and immutable bindings, module environment records also provide immutable import bindings, which are bindings that provide indirect access to a target binding that exists in another environment record. Module environment records support all of the declarative environment record methods listed in Table 16 and share the same specifications for all of those methods except for get binding value, delete binding, has this binding, and get this binding. In addition, module environment records support the methods listed in Table 22. Table 22, additional methods of module environment records. The behavior of the additional concrete specification methods for module environment records are defined by the following algorithms. 1, 1, 5, 1 get binding value, n, s. The get binding value concrete method of a module environment record envrec takes arguments n, a string, and s, a boolean, and returns either a normal completion containing an ECMAScript language value or a throw completion. It returns the value of its bound identifier whose name is n. However, if the binding is an indirect binding, the value of the target binding is returned. If the binding exists but is uninitialized, a reference error is thrown. It performs the following steps when called. Assert. S is true. Assert. envrec has a binding for n. If the binding for n is an indirect binding, then a let m and n2 be the indirection values provided when this binding for n was created. B let target env be m. C if target env is empty, throw a reference error exception. D return target env get binding value. N2, true. If the binding for n in envrec is an uninitialized binding, throw a reference error exception. Return the value currently bound to n in envrec. Note: S will always be true because a module is always strict mode. Code 9. 1, 1, 5. To delete binding, n. The delete binding concrete method of a module environment record is never used within this specification. Method. Purpose. Create import binding, n, m, n2. Create an immutable indirect binding in a module environment record. The string value n is the text of the bound name. M is a
I finally found what I was looking for.
environment record.
I edited it,
Turn the value.
and then I built it. and it changed.
Copyright.
So now I can try to find where that string's being appended to the output.
49.
And then move it to like one stupid
Used within strict code in an early error rule prevent
side or whatever to the other
code.
to pick what file goes in.
That would resolve to a module environment record binding. C135111,1,5 3 has this binding. That has this binding concrete method of a module.
I had like a container thing that had things inside of it.
It performs the following steps when
And I was looking at the container name thinking that was the name, but it's, I don't know, it's
concrete method of
complicated or whatever.
takes no arguments and completion containing undefined.
Yeah,
Return undefined. 5 create import by
it's not even worth explaining.
2. The create import binding concrete method of a module environment record envrec takes arguments n, a string, m, a module record, and n2, a string, and returns unused. It creates a new initialized immutable indirect binding for the name n. A binding must not already exist in this environment record for n. N2 is the name of a binding that exists in m's module environment record. Accesses to the value of the new binding will indirectly access the bound value of the target binding. It performs the following steps when called. Assert. envrec does not already have a binding for n. Assert. When m is instantiated, it will have a direct binding for n2. Create an immutable indirect binding in envrec for n that references m and n2 as its target binding and record that the binding is initialized. Return unused. 1.2 environment record operations. The following abstract operations are used in this specification to operate upon environment records. 9. 1. 2. 1 get identifier reference. env. Name. Strict. The abstract operation get identifier reference takes arguments env, an environment record or null, name, a string, and strict, a boolean, and returns either a normal completion containing a reference record or a throw completion. It performs the following steps when called. If env is null, then a return the reference record, unresolvable, name, strict. This value, empty. Let exists be env has binding. Name. If exists is true, then a return the reference record. env, name, strict, empty. Else. 150. ECMA International 2024. Note, module environment records always provide this binding. AB. Let outer be env. Return. Get identifier reference. Outer. Name. Strict. 9. 1. 2. To new declarative environment. E. The abstract operation new declarative environment takes argument E, an environment record or null, and returns a declarative environment record. It performs the following steps when called. Let env be a new declarative environment record containing no bindings. Set env to E. Return env, 1, 2, 3 new object environment. O. W. E. The abstract operation new object environment takes arguments O, an object, W, a boolean, and E, an environment record or null, and returns an object environment record. It performs the following steps when called. Let env be a new object environment record. Set env to O, set env to W, set env to E. Return env, 1, 2, 4 new function environment. F. New target. The abstract operation new function environment takes arguments F, an ECMAScript function object, and new target, an object or undefined, and returns a function environment record. It performs the following steps when called. Let env be a new function environment record containing no bindings. Set env to F. If F is lexical, set env to lexical. Else, set env to uninitialized. Set env to new target. Set env to F. Return env, 1, 2, 5 new global environment. G. This value. The abstract operation new global environment takes arguments G, an object, and this value, an object, and returns a global environment record. It performs the following steps when called. Let objrec be new object environment. G. False. Null. Let dclrec be new declarative environment. null. Let env be a new global environment record. Set env to objrec. Set env to this value. Set env to dclrec. Set env to a new empty list. Set env to null. Return env, 1, 2, 6 new module environment. The abstract operation new module environment takes argument E, an environment record, and returns a module environment record. It performs the following steps when called. Let env be a new module environment record containing no bindings. Set env to E. Return env, ECMA International 2024 151, 9.2 Private environment records. A private environment record is a specification mechanism used to track private names based upon the lexical nesting structure of class declarations and class expressions in ECMAScript code. They are similar to, but distinct from, environment records. Each private environment record is associated with a class declaration or class expression. Each time such a class is evaluated, a new private environment record is created to record the private names declared by that class. Each private environment record has the fields defined in Table 23. Table 23. Private environment record fields. Field name, value type, meaning, outer private environment. A. Private environment record or null. The private environment record of the nearest containing class null if the class with which this private environment record is associated is not contained in any other class. Names, a list of private names. The private names declared by this class. 9, 2. 1 Private environment record operations. The following abstract operations are used in this specification to operate upon private environment records. 9, 2, 1. 1 new private environment. outerprivy-env. The abstract operation new private environment takes argument outerprivy-env, a private environment record or null, and returns a private environment record. It performs the following steps when called. Let names be a new empty list. Return the private environment record. outerprivy-env, names, 2, 1. To resolve private identifier, privy-env, identifier. The abstract operation resolve private identifier takes arguments privy-env, a private environment record, and identifier, a string, and returns a private name. It performs the following steps when called. Let names be privy-env. For each private name Pn of names, do if Pn is identifier. Then I return Pn. Let outerprivy-env be privy-env. Assert. outerprivy-env is not null. Return resolve private identifier. outerprivy-env, identifier. 3 realms. Before it is evaluated, all ECMAScript code must be associated with a realm. Conceptually, a realm consists of a set of intrinsic objects, an ECMAScript global environment, all of the ECMAScript code that is loaded within the scope of that global environment, and other associated state and resources. A realm is represented in this specification as a realm record with the fields specified in Table 24, 52, copyright sign, ECMA International 2024, Table 24, realm record fields, field name, agent signifier, intrinsics, global object, global env, template map, an object or undefined value, an agent signifier, a record whose field names are intrinsic keys and whose values are objects, a global environment record, a list of records with fields, a template literal, parse node, and v, an array, F, the agent that owns this realm, the global object for this realm, the global environment for this realm, meaning the intrinsic values used by code associated with this realm, a list of records with fields are a string and a module record. Note 1 once a parse node becomes unreachable, the corresponding is also unreachable, and it would be unobservable if an implementation removed the pair from the list. Anything default value is undefined. Note 2 as mentioned in host load imported module 16.2.1.8. Note 1, in realm records is only used when running an import expression in a context where there is no active script or module, field reserved for use by hosts that need to associate additional information with a realm record. Template objects are canonicalized separately for each realm using its realm records. Each value is a parse node that is a template literal. The associated ALU is the corresponding template object that is passed to a tag function, a map from the specifier strings imported by this realm to the solved module record. The list does not contain two different records with the same 9, 3, 1 create realm. The abstract operation create realm takes no arguments and returns a realm record. It performs the following steps when called. Let realm rec be a new realm record. Perform create intrinsics. Realm rec. Set realm rec to agent signifier. Set realm rec to undefined. Set realm rec to undefined. Set realm rec to a new empty list. Return realm rec. ECMA International 2024 153 9 3 2 create intrinsics. Realm re. C. The abstract operation create intrinsics takes argument realm rec, a realm record, and returns unused. It performs the following steps when called. Set realm rec to a new record. Set fields of realm rec with the values listed in table 6. The field names are the names listed in column 1 of the table. The value of each field is a new object value fully and recursively populated with property values as defined by the specification of each object in clauses 19 through 28. All object property values are newly created object values. All values that are built-in function objects are created by performing create built-in function, steps, length, name, slots, realm rec, prototype, where steps is the definition of that function provided by this specification. Name is the initial value of the function's name property. Length is the initial value of the function's length property. Slots is a list of the names, if any, of the function's specified internal slots. And prototype is the specified value of the function's internal slot. The creation of the intrinsics and their properties must be ordered to avoid any dependencies upon objects that have not yet been created. Perform. Capital A, D, D, capital R, E, S, T, R, I, C, T, E, D, capital F, U, N, C, T, I, O, N, capital P, R, O, P, E, R, T, I, E, realm rec. Realm rec. Return unused. 3.3 set realm global object. Realm rec. Global obj. This value. The abstract operation set realm global object takes arguments realm rec, a realm record, global obj, an object or undefined, and this value, an object or undefined, and returns unused. It performs the following steps when called. If global obj is undefined, then a let intrinsics be realm rec, be set global obj to ordinary object create intrinsics. Assert global obj is an object. If this value is undefined, set this value to global obj. Set realm rec to global obj. Let new global env be new global environment. Global obj. This value. Set realm rec to new global env. Return unused. 3.4 set default global bindings. Realm rec. The abstract operation set default global bindings takes argument realm rec, a realm record, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let global be realm rec. For each property of the global object specified in clause 19. Do a let name be the string value of the property name. B let desk be the fully populated data property descriptor for the property, containing the specified attributes for the property. For properties listed in 19.2, 19.3, or 19.4, the value of the attribute is the corresponding intrinsic object from realm rec. See perform. Define property or throw global name desk return global. Point 4 execution contexts. An execution context is a specification device that is used to track the runtime evaluation of code by an ECMAScript I implementation. At any point in time, there is at most one execution context per agent that is actually executing code. This is known as the agent's running execution context. All references to the running execution context in this specification denote the running execution context of the surrounding agent. The execution context stack is used to track execution contexts. The running execution context is always the top element of this stack. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with that. 54. Copyright sign, ECMA International 2024 Execution Context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever implementation-specific state is necessary to track the execution progress of its associated code. Each execution context has at least the state components listed in Table 25. Table 25. State components for all execution contexts. Component. Purpose. Code evaluation state. Any state needed to perform, suspend, and resume evaluation of the code associated with this execution context. Function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of a script or module, the value is null. Realm. The realm record from which associated code accesses ECMAScript resources. Script or module. The module record or script record from which associated code originates. If there is no originating script or module, as is the case for the original execution context created in initialize host-defined realm, the value is null. Evaluation of code by the running execution context may be suspended at various points defined within this specification. Once the running execution context has been suspended, a different execution context may become the running execution context and commence evaluating its code. At some later time, a suspended execution context may again become the running execution context and continue evaluating its code at the point where it had previously been suspended. Transition of the running execution context status among execution contexts usually occurs in stack-like last-in first-out manner. However, some ECMAScript features require non-LFO transitions of the running execution context. The value of the realm component of the running execution context is also called the current realm record. The value of the function component of the running execution context is also called the active function object. ECMAScript code execution contexts have the additional state components listed in Table 26. Table 26. Additional state components for ECMAScript code execution contexts. Component. Purpose. Lexical environment. Identifies the environment record used to resolve identifier references made by code within this execution context. Variable environment. Identifies the environment record that holds bindings created by variable statements within this execution context. Private environment. Identifies the private environment record that holds private names created by class elements and the nearest containing class null if there is no containing class. The lexical environment and variable environment components of an execution context are always environment records. Execution contexts representing the evaluation of generators have the additional state components listed in Table 27. ECMA International 2024 155. Table 27. Additional state components for generator execution contexts. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment and variable environment are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for ECMAScript code to directly access or observe an execution context. 4.1 Get active script or module. The abstract operation get active script or module takes no arguments and returns a script record, a module record, or null. It is used to determine the running script or module based on the running execution context. It performs the following steps when called. If the execution context stack is empty, return null. Let EC be the topmost execution context on the execution context stack whose script or module component is not null. If no such execution context exists, return null. Otherwise, return X script or module. 4.2 Resolve binding. Name. env. The abstract operation resolve binding takes argument name, a string, and optional argument env, an environment record or undefined, and returns either a normal completion containing a reference record or a throw completion. It is used to determine the binding of name. env can be used to explicitly provide the environment record that is to be searched for the binding. It performs the following steps when called. If env is not present or env is undefined, Then, A set env to the running execution context's lexical environment. Assert. env is an environment record if the source text matched by the syntactic production that is being evaluated is contained in strict mode. Code. Let strict be true, else let strict be false. Return. Get identifier reference. env. Name. Strict, 4.3 get this environment. The abstract operation get this environment takes no arguments and returns an environment record. It finds the environment record that currently supplies the binding of the keyword this. It performs the following steps when called. Let env be the running execution context's lexical environment. NT2. Repeat. Component purpose. Generator the generator that this execution context is evaluating. 156. ECMA International 2024. Note the result of resolved binding is always a reference record whose field is name. ABCDE. Let exists be env has this binding. If exists is true, return env. Let outer be env. Assert. Outer is not null. Set env to outer. Note the loop in step 2 will always terminate because the list of environments always ends with the global environment which has this binding. 4.4 resolve this binding. The abstract operation resolve this binding takes no arguments and returns either a normal completion containing an ECMAScript language value or a throw completion. It determines the binding of the keyword thus using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Return env-rec get this binding. 4.5 get new target. The abstract operation get new target takes no arguments and returns an object or undefined. It determines the new target value using the lexical environment of the running execution context. It performs the following steps when called. Let env-rec be get this environment. Assert. env-rec has a field. Return env-rec, 4.6 get global object. The abstract operation get global object takes no arguments and returns an object. It returns the global object used by the currently running execution context. It performs the following steps when called. 2.5. Let current realm be the current realm record. Return current realm, jobs and host operations to enqueue jobs. A job is an abstract closure with no parameters that initiates an ECMAScript computation when no other ECMAScript computation is currently in progress. Jobs are scheduled for execution by ECMAScript host environments in a particular agent. This specification describes the host hook's host enqueue generic job. Capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R host enqueue promise job and host enqueue timeout job to schedule jobs. The host hooks in this specification are organized by the additional constraints imposed on the scheduling of jobs. Hosts may define additional abstract operations which schedule jobs. Such operations accept a job abstract closure and a realm record or null, as parameters. If a realm record is provided, these operations schedule the job to be performed at some future time in the provided realm, in the agent that owns the realm. If null is provided instead for the realm, then the job does not evaluate ECMAScript code. Their implementations must conform to the following requirements. At some future point in time, when there is no running context in the agent for which the job is scheduled and that agent's execution context stack is empty, the implementation must perform any host-defined preparation steps. Invoke job abstract closure, perform any host-defined cleanup steps, after which the execution context stack must be empty. Only one job may be actively undergoing evaluation at any point in time in an agent. Once evaluation of a job starts, it must run to completion before evaluation of any other job starts in an agent. The abstract closure must return a normal completion, implementing its own handling of errors. ECMA International 2024 157. Note: one host environments are not required to treat jobs uniformly with respect to scheduling. For example, web browsers and Node.js treat promise handling jobs as a higher priority than other work, Future features may add jobs that are not treated at such a high priority at any particular time. Script or module, a script record, a module record, or null, is the active script or module if all of the following conditions are true. Get active script or module. Is script or module. If script or module is a script record or module record, let EC be the topmost execution context on the execution context stack whose script or module component is script or module. The realm component of EC is script or module. At any particular time, an execution is prepared to evaluate ECMAScript code if all of the following conditions are true. The execution context stack is not empty. The realm component of the topmost execution context on the execution context stack is a realm record. Particular kinds of jobs have additional conformance requirements. 5.1 Job callback records. A job callback record is a record value used to store a function object and a host-defined value. Function objects that are invoked via a job enqueued by the host may have additional host-defined context. To propagate the state, job abstract closures should not capture and call function objects directly. Instead, use host make job callback and host call job callback. Job callback records have the fields listed in Table 28. Table 28. Job callback record fields. 5.2 Host make job callback. Callback, the host-defined abstract operation host make job callback takes argument callback, a function object, and returns a job callback record. An implementation of host make job callback must conform to the following requirements. It must return a job callback record whose field is callback. Note: 2 host environments may prepare an execution to evaluate code by pushing execution contexts onto the execution context stack. The specific steps are implementation defined. The specific choice of realm is up to the host environment. This initial execution context and realm is only in use before any callback function is invoked. When a callback function related to a job, like a promise handler, is invoked, the invocation pushes its own execution context and realm. Note the WHATWG specification, https://html.spec.whatwg.org/ For example, uses the host-defined value to propagate the incumbent settings object for promise callbacks. Field name value meaning callback, a function object, the function to invoke when the job is invoked. Host defined, anything default value is empty. Field reserved for use by hosts. 158. ECMA International 2024. The default implementation of host make job callback performs the following steps when called. 1. Return the job callback record. Callback empty. ECMAScript hosts that are not web browsers must use the default implementation of host make job callback. 5.3 Hosts call job callback. Job callback v. Arguments list. The host-defined abstract operation host call job callback takes arguments job callback, a job callback record, v. an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. An implementation of host call job callback must conform to the following requirements. It must perform and return the result of call job callback v. Arguments list. The default implementation of host call job callback performs the following steps when called. Assert is callable. Job callback is true. Return call job callback v. Arguments list. ECMAScript hosts that are not web browsers must use the default implementation of host call job callback. 5.4 Host enqueue generic job realm. The host-defined abstract operation host enqueue generic job takes arguments job, a job abstract closure, and realm, a realm record, and returns unused. It schedules job in the realm in the agent signified by realm to be performed at some future time. The abstract closures used with this algorithm are intended to be scheduled without additional constraints, such as priority and ordering. An implementation of host enqueue generic job must conform to the requirements in 9.5 host enqueue promise job realm. The host-defined abstract operation host enqueue promise job takes arguments job, a job abstract closure, and realm, a realm record or null, and returns unused. It schedules job to be performed at some future time. The abstract closures used with this algorithm are intended to be related to the handling of promises, or otherwise, to be scheduled with equal priority to promise handling operations. An implementation of host enquire promise job must conform to the requirements in 9.5 as well as the following. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that execution is prepared to evaluate ECMAScript code at the time of job's invocation. Let script or module be get active script or module at the time host enquire promise job is invoked. If realm is not null, each time job is invoked, the implementation must perform implementation-defined steps such that script or module is the active script or module at the time of job's invocation. Jobs must run in the same order as the host enquire promise job invocations that scheduled them. Note this is called at the time that the callback is passed to the function that is responsible for its being eventually scheduled and run. For example, promise then action, calls make job callback on then action at the time of invoking promise prototype then, not at the time of scheduling the reaction job. Note this requirement means that hosts cannot change the behavior of function objects defined in this specification. ECMA International 2024 159. Note the realm for jobs returned by new promise resolved thenable job is usually the result of calling get function realm on the then function object. The realm for jobs returned by new promise reaction job is usually the result of calling get function realm on the handler if the handler is not undefined. If the handler is undefined, realm is null. For both kinds of jobs, when get function realm completes abnormally, that is called on a revoked proxy, realm is the current realm record at the time of the get function realm call. When the realm is null, no user ECMAScript code will be evaluated and no new ECMAScript objects, for example, error objects, will be created. The WHATWG-HTML specification, https://html.spec.whatwg.org/ for example, uses realm to check for the ability to run script and for the entry, https://html.spec.whatwg.org/ /entry concept, 5.6 host enquire timeout job, realm, milliseconds. The host-defined abstract operation host enquire timeout job takes arguments timeout job, a job abstract closure, realm, a realm record, and milliseconds, a non-negative finite number, and returns unused. It schedules timeout job in the realm in the agent signified by realm to be performed after at least milliseconds. An implementation of host enquire timeout job must conform to the requirements in 9.5, 9.6 initialize host-defined realm. The abstract operation initialize host-defined realm takes no arguments and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Let realm be create realm. Let new context be a new execution context. Set the function of new context to null. Set the realm of new context to realm. Set the script or module of new context to null. Push new context onto the execution context stack. New context is now the running execution context. If the host requires use of an exotic object to serve as realm's global object, let global be such an object created in a host-defined manner. Otherwise, let global be undefined, indicating that an ordinary object should be created as the global object. If the host requires that this binding in realm's global scope return an object other than the global object, let this value be such an object created in a host-defined manner. Otherwise, let this value be undefined, indicating that realm's global this binding should be the global object. 9. Perform set realm global object, realm, global. This value 0. Let global obj be. Set default global bindings, realm 1. Create any host-defined global object properties on global obj 2. Return unused. 7 agents. An agent comprises a set of ECMAScript execution contexts, an execution context stack, a running execution context, an agent record, and an executing thread. Except for the executing thread, the constituents of an agent belong exclusively to that the agent. An agent's executing thread executes algorithmic steps on the agent's execution contexts independently of other agents, except that an executing thread may be used as the executing thread by multiple agents, provided none of the agents sharing the thread have an agent record whose field is true. Note 1. Some web browsers share a single executing thread across multiple unrelated tabs of a browser window. For example, 60, copyright sign, ECMA International 2024. While an agent's executing thread is executing algorithmic steps, the agent is the surrounding agent for those steps. The steps use the surrounding agent to access the specification-level execution objects held within the agent, the running execution context, the execution context stack, and the agent records fields. An agent signifier is a globally unique opaque value used to identify an agent. Table 29. Agent record fields. Field name, value, meaning, little endian, a boolean, the default value computed for the isLittleEndian parameter when it is needed by the algorithm's get value from buffer and set value in buffer. The choice is implementation defined and should be the alternative that is most efficient for the implementation. Once the value has been observed, it cannot change. Can block. A boolean determines whether the agent can block or not. Signifier. An agent signifier uniquely identifies the agent within its agent cluster. Is lock-free 1. A boolean, true if atomic operations on 1-byte values are lock-free. False otherwise. Is lock-free 2. A boolean, true if atomic operations on 2-byte values are lock-free. False otherwise. Is lock-free 8. A boolean, true if atomic operations on 8-byte values are lock-free. False otherwise. Candidate execution. A. Candidate execution record. See the memory model. Kept alive. A list of either objects or symbols. Initially a new empty list, representing the list of objects and or symbols to be kept alive until the end of the current job. Once the values of and have been observed by any agent in the agent cluster, they cannot change. Note 2. The values of and are not necessarily determined by the hardware, but may also reflect implementation choices that can vary over time and between ECMAScript implementations. There is no field. 4-byte atomic operations are always log-free. In practice, if an atomic operation is implemented with any type of lock, the operation is not lock-free. Lock-free does not imply wait-free. There is no upper bound on how many machine steps may be required to complete a lock-free atomic operation. That an atomic access of size n is lock-free does not imply anything about the perceived atomicity of non-atomic accesses of size n. Specifically, non-atomic accesses may still be performed as a sequence of several separate memory accesses. See read shared memory and write shared memory for details. ECMA International 2024 161. Note 3. An agent is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. 7.1 Agent signifier. The abstract operation agent signifier takes no arguments and returns an agent signifier. It performs the following steps when called. Let AR be the agent record of the surrounding agent. Return AR, 7.2 Agent can suspend. The abstract operation agent can suspend takes no arguments and returns a boolean. It performs the following steps when called. 2.8 Let AR be the agent record of the surrounding agent. Return AR, agent clusters. Note in some environments it may not be reasonable for a given agent to suspend. For example, in a web browser environment, it may be reasonable to disallow suspending a document's main event handling thread, while still allowing workers' event handling threads to suspend. An agent cluster is a maximal set of agents that can communicate by operating on shared memory. Every agent belongs to exactly one agent cluster. All agents within a cluster must have the same value for the field in their respective agent records. All agents within a cluster must have the same values for the field in their respective agent records. Similarly for the field, all agents within a cluster must have different values for the field in their respective agent records. An embedding may deactivate, stop forward progress, or activate, resume forward progress, an agent without the agent's knowledge or cooperation. If the embedding does so, it must not leave some agents in the cluster active while other agents in the cluster are deactivated indefinitely. Note 1. Programs within different agents may share memory by unspecified means. At a minimum, the back-end memory for shared array buffers can be shared among the agents in the cluster. There may be agents that can communicate by message passing that cannot share memory. They are never in the same agent cluster. Note 2. The agents in a cluster need not all be alive at some particular point in time. If agent A creates another agent B, after which A terminates and B creates agent C. The three agents are in the same cluster if A could share some memory with B and B could share some memory with C. Note 3: if different agents within an agent cluster have different values of it becomes hard to use shared memory for multi-byte data. 62. Copyright sign, ECMA International 2024.
I got one chunk. Isolate whatever. I just gotta get this bottom. I got this I gotta like pull in this part. I don't know. Almost done. I need some water.
Worker will be blocked until the dedicated worker is activated again, if ever. Meanwhile, other workers trying to access the shared worker from other windows will starve. The implication of the restriction is that it will not be possible to share memory between agents that don't belong to the same suspend wake collective within the embedding. An embedding may terminate an agent without any of the agent's cluster's other agents' prior knowledge or cooperation. If an agent is terminated not by programmatic action of its own or of another agent in the cluster but by forces external to the cluster, then the embedding must choose one of two strategies: either terminate all the agents in the cluster, or provide reliable APIs that allow the agents in the cluster to coordinate so that at least one remaining member of the cluster will be able to detect the termination. With the termination data containing enough information to identify the agent that was terminated, each of the following specification values, and values transitively reachable from them, belong to exactly one agent cluster. Candidate execution record, shared data block, wait list record. Prior to any evaluation of any ECMAScript code by any agent in a cluster, the field of the agent record for all agents in the cluster is set to the initial candidate execution. The initial candidate execution is an empty candidate execution whose field is a list containing, for each agent, an agent events record whose field is that agent's agent signifier, and whose fields are empty lists. Note 5 examples of that type of termination are operating systems or users terminating agents that are running in separate processes, the embedding itself terminating an agent that is running in process with the other agent's WinPer. Agent resource accounting indicates that the agent is runaway. Note 6: all agents in an agent cluster share the same candidate execution in its agent records field. The candidate execution is a specification mechanism used by the memory model. Note 7: an agent cluster is a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. Point 9: forward progress. For an agent to mark forward progress is for it to perform an evaluation step according to this specification. An agent becomes blocked when it's running execution context waits synchronously and indefinitely for an external event. Only agents whose agent records field is true can become blocked in this sense. An unblocked agent is one that is not blocked. Implementations must ensure that every unblocked agent with a dedicated executing thread eventually makes forward progress. In a set of agents that share an executing thread, one agent eventually makes forward progress. ECMA International 2024 163. An agent does not cause another agent to become blocked except via explicit APIs that provide blocking. Point 10: processing model of weak ref and finalization registry targets 9.10.1 objectives. This specification does not make any guarantees that any object or symbol will be garbage collected. Objects or symbols which are not live may be released after long periods of time, or never at all. For this reason, this specification uses the term may when describing behavior triggered by garbage collection. The semantics of weak refs and finalization registries is based on two operations which happen at particular points in time. When weak ref prototype derf is called, the referent, if undefined is not returned, is kept alive so that subsequent...
This is taking way too long to figure out. I have like in JavaScript functions that like append data to make like a big data blob and I loop through the whole thing at the end. But there's like some parts where I put things like outside of the data blob and there's separate loops and I'm like gluing strings together in weird spots. And I'm trying to like track down where that string is being used because I use it in 3 or 4 spots to be lazy. So now I'm trying to like separate it up without breaking the other things and pulling out another part. I don't know, it's just stupid. I should have wrote this all different.
Clean up script execution in order to run finalize.
Like one part left. Separate from the rest and then put it to the other window or text box. And this stuff's done. And then after this stuff
always returns undefined. This
all stuff is like a handful of macros that I have to check to make sure like int's a cast, not a keyword that gets concatenated.
Greph it. Self does not keep its referent alive.
And I'm on 64-bit addressing. This is all I want to do. So we're done.
Reasoning. Note 2 weak ref obliviousness is defined on sets of objects or symbols.
This is so laggy. It's just stuck now.
Then a weak ref referent in a cycle will be considered live even though its identity.
Windows 11 does not run very good on really old CPUs. Like obviously. Of course it wouldn't. I don't know, whatever.
And or symbols S is considered live if either of the following conditions is met. Any element in S include any list 104. Internet.
I need to focus.
Graph oblivious execution with respect to S that observes the identity of any value in S. Note for the second condition above intends to capture the intuition that a value is live if its identity is observable via non-weak ref means. A value's identity may be observed by observing a strict equality comparison or observing the value being used as key in a map. Note 5. Presence of an object or a symbol in a field, an internal slot, or a property does not imply that the value is live. For example, if the value in question is never passed back to the program, then it cannot be observed. This is the case for keys in a weak map, members of a weak set, as well as the infields of a finalization registry cell record. The above definition implies that, if a key in a weak map is not live, then its corresponding value is not necessarily live either. Note 6 liveness is the lower bound for guaranteeing which weak refs engines must not empty. Liveness is defined here as undecidable. In practice, engines use conservative approximations such as reachability. There is expected to be significant implementation leeway. 10.3 Execution. At any time, if a set of objects and or symbols S is not live, an ECMAScript implementation may perform the following steps atomically. For each element value of S, do a for each weak ref such that ref is value. Do I set ref to empty. B for each finalization registry FG such that FG contains a record cell such that cell is value. Do I set cell to empty. 2. Optionally, perform capital H O S T capital E N Q U E U E capital F I N A L I Z A T I O N capital R E G I S T R F G. C for each weak map such that map contains a record R such that R value. Do I set R to set R to empty. D for each weak set such that set contains value. Do I replace the element of set whose value is value W with an element whose value is empty. ECMA International 2024 165. Note 1. Together with the definition of liveness, this clause prescribes optimizations that an implementation may apply regarding weak refs. It is possible to access an object without observing its identity. Optimizations such as dead variable elimination and scalar replacement on properties of non-escaping objects whose identity is not observed are allowed. These optimizations are thus allowed to observably empty weak refs that point to such objects. On the other hand, if an object's identity is observable, and that object is in the internal slot of a weak ref, optimizations such as rematerialization that observably empty the weak ref are prohibited, because calling capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, is optional. Registered objects in a finalization registry do not necessarily hold that finalization registry live. Implementations may omit finalization registry callbacks for any reason. For example, if the finalization registry itself becomes dead, or if the application is shutting down. Note 2. Implementations are not obligated to empty weak refs for maximal sets of non-live objects or symbols. If an implementation chooses a non-live set S in which to empty weak refs, this definition requires that it empties weak refs for all values in S simultaneously. In other words, it is not conformant for an implementation to empty a weak ref pointing to a value v without emptying out other weak refs that, if not emptied, could result in an execution that observes the value of v, 10.4 host hooks, 1041, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, finalization registry, the host-defined abstract operation, capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, takes argument finalization registry, a finalization registry, and returns unused. Let cleanup job be a new job abstract closure with no parameters that captures finalization registry and performs the following steps when called. Let cleanup result be completion. Cleanup finalization registry. Finalization registry. If cleanup result is an abrupt completion, perform any host-defined steps for reporting the error. Return unused. An implementation of capital H, O, S, T, capital E, N, Q, U, E, U, E, capital F, I, N, A, L, I, Z, A, T, I, O, N, capital R, E, G, I, S, T, R, schedules cleanup job to be performed at some future time, if possible. It must also conform to the requirements in 9.5.11 clear-kept objects. The abstract operation clear-kept objects takes no arguments and returns unused. ECMAScript implementations are expected to call clear-kept objects when a synchronous sequence of ECMAScript executions completes. It performs the following steps when called. Let agent record be the surrounding agent's agent record. Set agent record to a new empty list. Return unused. 66. ECMA International 2024. 9.12. Add to kept objects. Value. The abstract operation add to kept objects takes argument value, an object or a symbol, and returns unused. It performs the following steps. W. When called, let agent record be the surrounding agent's agent record. Append value to agent record. Return unused. 0.13. Cleanup finalization registry. Finalization registry. The abstract operation cleanup finalization registry takes argument finalization registry, a finalization registry, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. Assert. Finalization registry has an internal slots. Let callback be finalization registry. While finalization registry contains a record cell such that cell is empty, an implementation may perform the following steps. A choose any such cell. B remove cell from finalization registry. C perform host call job callback, undefined, cell, return unused. 0.14 can be held weekly. V. The abstract operation can be held weekly takes argument V, an ECMAScript language value, and returns a boolean. It returns true if and only if V is suitable for use as a weak reference. Only values that are suitable for use as a weak reference may be a key of a weak map, an element of a weak set, the target of a weak ref, or one of the targets of a finalization registry. It performs the following steps when called. If V is an object, return true. If V is a symbol and key for symbol, V is undefined, return true. Return false. Note when the abstract operation add to kept objects is called with a target, object, or symbol, it adds the target to a list that will point strongly at the target until clear kept objects is called. Note a language value without language identity can be manifested without prior reference and is unsuitable for use as a weak reference. A symbol value produced by symbol 4, unlike other symbol values, does not have language identity and is unsuitable for use as a weak reference. Well-known symbols are likely to never be collected, but are nonetheless treated as suitable for use as a weak reference because they are limited in number and therefore manageable by a variety of implementation approaches. However, any value associated to a well-known symbol in a live weak map is unlikely to be collected and could leak memory resources in implementations. 0. Ordinary and exotic objects behaviors. 0.1 Ordinary object internal methods and internal slots. All ordinary objects have an internal slot called. The value of this internal slot is either null or an object and is used for implementing inheritance. Assume a property named P is missing from an ordinary object O but exists on its object. If P refers to a data property on the object, O inherits it for get access, making it behave as if P was a property of O if P refers to a writable data property on the ECMA International 2024 167 object. Set access of P on O creates a new data property named P on O if P refers to a non-writable data property on the object. Set access of P on O fails. If P refers to an accessor property on the object, the accessor is inherited by O for both get access and set access. Every ordinary object has a Boolean valued internal slot which is used to fulfill the extensibility related internal method invariance specified in 6.1.7.3. Namely, once the value of an object's internal slot has been set to false, it is no longer possible to add properties to the object, to modify the value of the object's internal slot, or to subsequently change the value of to true. In the following algorithm descriptions, assume O is an ordinary object, P is a property key value, V is any ECMAScript language value, and ESC is a property descript to record. Each ordinary object internal method delegates to a similarly named abstract operation. If such an abstract operation depends on another internal method, then the internal method is invoked on O rather than calling the similarly named abstract operation directly. These semantics ensure that exotic objects have their overridden internal methods invoked when ordinary object internal methods are applied to them. 0, 1. 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing either an object or null. It performs the following steps when called. Return ordinary get prototype of O10, 1, 1. 1 ordinary get prototype of O. The abstract operation ordinary get prototype of takes argument O, an object, and returns an object or null. It performs the following steps when called. Return O10, 1, 2. V. The internal method of an ordinary object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary set prototype of O. V10, 1, 2. 1 ordinary set prototype of O. V. The abstract operation ordinary set prototype of takes arguments O, an object, and V, an object or null, and returns a boolean. It performs the following steps when called. Let current be O if same value, V, current, is true. return true. Let extensible be O. If extensible is false, return false. Let bev. Let done be false. Repeat. While done is false. If P is null, then I set done to true. B else if same value, P, O, is true, then I return false. C else, if P is not the ordinary object internal method defined in 1, 0, 1, 1, set done to true. 2. Else, set P to P, set O to V, return true. 68. ECMA International 2024. Note the loop in step 7 guarantees that there will be no circularities in any prototype chain that only includes objects that use the ordinary object definitions. For and 0, 1, 3. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a boolean. It performs the following steps when called. Return ordinary is extensible. O1, 0, 1, 3. 1 ordinary is extensible. O. The abstract operation ordinary is extensible takes argument O, an object, and returns a boolean. It performs the following steps when called. Return O1, 0, 1, 4. The internal method of an ordinary object O takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return ordinary prevent extensions. O1, 0, 1, 4. 1 ordinary prevent extensions. O. The abstract operation ordinary prevent extensions takes argument O, an object, and returns true. It performs the following steps when called. Set O to false. Return true. 0, 1, 5. P. The internal method of an ordinary object O takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Return ordinary get own property. O. P1, 0, 1, 5. 1 ordinary get own property. O. P. The abstract operation ordinary get own property takes arguments O, an object, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If O does not have a known property with key P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property whose key is P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else A assert X is an accessor property. B set D attribute. C set D attribute. ECMA International 2024 169. 6. Set D to the value of X's attribute. Set D to the value of X's attribute. Return D. 0, 1, 6. P. Desk. The internal method of an ordinary object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return ordinary define known property. O. P. Desk 1, 0, 1, 6. 1 ordinary define known property. O. P. Desk. The abstract operation ordinary define known property takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O. P. Let extensible be is extensible. O. Return validate and apply property desker. IPTA. O. P. Extensible. Desk. Current. 0, 1, 6. 2 is compatible property descriptor. Extensible. Desk. Current. The abstract operation is compatible property descriptor takes arguments extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. Return capital V, A, L, I, D, A, T, E, capital A, N, D, capital A, P, P, L, Y, capital P, R, O, P, E, R, T, Y, capital D, E, S, C, R, I, undefined, extensible, desk, current 1, 0, 1, 6, 3, capital V, A, L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I O P extensible desk current. The abstract operation capital V A L I D A T E capital A N D capital A P P L Y capital P R O P E R T Y capital D E S C R I takes arguments O, an object or undefined, P, a property key, extensible, a boolean, desk, a property descriptor, and current, a property descriptor or undefined, and returns a boolean. It returns true if and only if desk can be applied as the property of an object with specified extensibility and current property current while upholding invariance. When such application is possible and O is not undefined, it is performed for the property named P, which is created if necessary. It performs the following steps when called. Assert is property key, P is true if current is undefined. Then, if extensible is false, return false. B if O is undefined, return true. C if is accessor descriptor, desk, is true. Then, I create an own accessor property named P of object O whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. Else, I create a known data property named P of object O whose and configurable attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value, otherwise you return true. Assert current is a fully populated property descriptor. If desk does not have any fields, return true. If current is false, then 70. ECMA International 2024. ABC. If desk has a field and desk is true, return false. If desk has an field and desk is not current, return false. If is generic descriptor, desk, is false and is accessor descriptor, desk, is not is accessor descriptor, current, return false. D if is accessor descriptor, current, is true, then I if desk has a current. 2. If desk has a current. Else if current is false, then I if desk has a field and desk is true, return false. 2. If desk has a field and same value, desk, current, is false, return false. If O is not undefined, then if is data descriptor, current, is true and is accessor descriptor, desk, is true, then I if desk has a configurable field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with an accessor property whose and attributes are set to configurable and enumerable, respectively, and whose attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. B else if is accessor descriptor, current, is true and is data descriptor, desk, is true, then I if desk has a field, let configurable be desk, else let configurable be current. 2. If desk has a field, let enumerable be desk, else let enumerable be current. 3. Replace the property named P of object O with a data property whose and enumerable attributes are set to configurable and enumerable, respectively, and whose and attributes are set to the value of the corresponding field in desk if desk has that field, or to the attribute's default value otherwise. C else, I for each field of desk, set the corresponding attribute of the property named P of object O to the value of the field 7. Return true. 0, 1, 7, P. The internal method of an ordinary object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Return. Ordinary has property O, P, 0, 1, 7, 1. Ordinary has property O, P, The abstract operation ordinary has property takes argument so, an object, and p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let has own be O, p, if his own is not undefined, return true. Let parent be O, if parent is not null, then a return parent, p5. Return false, 0, 1, 8. The return ordinary get O, p, receiver, ECMA International 2024 171, 10, 1, 8, 1 ordinary get O, p, receiver. The abstract operation ordinary get takes argument so, an object, p, a property key, and receiver, an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let desk be O, p, if desk is undefined, then a let parent be O, b if parent is null, return undefined. C return parent if is data descriptor, desk, is true, return desk. Assert is accessor descriptor, desk, is true. Let getter be desk. If getter is undefined, return undefined. Return call getter receiver 0, 1, 9. The return ordinary set O, p, v, receiver 1, 0, 1, 9, 1 ordinary set O, p, v, receiver. The abstract operation ordinary set takes argument so, an object, p, a property key, v, an ECMAScript language value, and receiver, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let own desk be O, p, return ordinary set with own descriptor O, p, v, receiver, own desk 0, 1, 9, 2 ordinary set with own descriptor O, p, v, receiver, own desk. The abstract operation ordinary set with own descriptor takes argument so, an object, p, a property key, v, an ECMAScript language value, receiver, an ECMAScript language value, and own desk, a property descriptor or undefined, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If own desk is undefined, then a let parent be O, b if parent is not null, then I return parent. I set own desk to the property descriptor, undefined, true, true, true if is data descriptor, own desk, is true, then 72 ECMA International 2024 ABCDE. If own desk is false, return false. If receiver is not an object, return false. Let existing descriptor be receiver, p. If existing descriptor is not undefined, then I if is accessor descriptor, existing descriptor, is true, return false. 2. If existing descriptor is false, return false. 3. Let value desk be the property descriptor, v, I've, return, receiver, p, value desk, else, I assert, receiver does not currently have a property p. 2. Return, create data property, receiver, p, v, assert, is accessor descriptor, own desk, is true. Let setter be own desk. If setter is undefined, return false. Perform, call, setter, receiver, v, return true, 0, 1, 1, 0, p. The internal method of an ordinary object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps. W, hen called, return, ordinary delete, O, p1, 0, 1, 1, 0, 1 ordinary delete, O, p. The abstract operation ordinary delete takes argument so, an object, and p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let desk be O, p. If desk is undefined, return true. If desk is true, then A remove the own property with name p from O. B return true. Return false. 0, 1, 1 1. The internal method of an ordinary object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Return ordinary own property keys, O1 0, 1, 1 1, 1 ordinary own property keys, O. The abstract operation ordinary own property keys takes argument O, an object, and returns a list of property keys. It performs the following steps when called. Let keys be a new empty list. For each own property key P of O such that P is an array index, in ascending numeric index order, do A append P to keys. For each own property key P of O such that P is a string and P is not an array index, in ascending chronological order of property creation, do A append P to keys. For each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do A append P to keys 5. Return keys 0, 1, 1 2. Ordinary object create, proto, additional internal slots list. The abstract operation ordinary object create takes argument proto an object or null, and optional argument additional internal slots list, a list of names of internal slots, and returns an object. It is used to specify the runtime creation of new ordinary objects. Additional internal slots list contains the names of additional internal slots. ECMA International 2024 173. That must be defined as part of the object. Beyond and. If additional internal slots list is not provided, a new empty list is used. It performs the following steps when called. Let internal slots list be. If additional internal slots list is present, set internal slots list to the list concatenation of internal slots list and additional internal slots list. Let O be make basic object. Internal slots list. Set O to proto. Return O. 0, 1, 1 3. Ordinary create from constructor. Constructor. Intrinsic default proto. Internal slots list. The abstract operation ordinary create from constructor takes arguments constructor, a constructor, and intrinsic default proto, a string, and optional argument internal slots list, a list of names of internal slots, and returns either a normal completion containing an object or a throw completion. It creates an ordinary object whose value is retrieved from a constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic def or LT proto is used for internal slots list contains the names of additional internal slots that must be defined as part of the object. If internal slots list is not provided, a new empty list is used. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get prototype from constructor. Constructor. Intrinsic default proto. If internal slots list is present, let slots list be internal slots list. Else, let slots list be a new empty list. Return ordinary object create. Proto. Slots list. 0, 1, 1 4. Get prototype from constructor. Constructor. Intrinsic default proto. The abstract operation get prototype from constructor takes arguments constructor, a function object, and intrinsic default proto, a string, and returns either a normal completion containing an object or a throw completion. It determines the value that should be used to create an object corresponding to a specific constructor. The value is retrieved from the constructor's prototype property, if it exists. Otherwise, the intrinsic named by intrinsic default proto is used for. It performs the following steps when called. Assert. Intrinsic default proto is this specification's name of an intrinsic object. The corresponding object must be an intrinsic that is intended to be used as the value of an object. Let proto be. Get. Constructor. Prototype. If proto is not an object, then let realm be. Get function realm. Constructor. Be set proto to realm's intrinsic object named intrinsic default proto. Return proto. Note, although ordinary object create does little more than call make basic object, its use communicates the intention to create an ordinary object, and not an exotic one. Thus, within this specification, it is not called by any algorithm that subsequently modifies the internal methods of the object in ways that would make the result non-ordinary. Operations that create exotic objects invoke make basic object directly. 174, ECMA International 2024. Note: if constructor does not supply a value, the default value that is used is obtained from the realm of the constructor function rather than from the running execution context. The 10th of January 2015 require internal slot. Internal slot. The abstract operation require internal slot takes arguments an ECMAScript language value, and internal slot, an internal slot name, and returns either a normal completion containing unused or a throw completion. It throws an exception unless O is an object and has the given internal slot. It performs the following steps when called. If O is not an object, throw a type error exception. If O does not have an internal slot, throw a type error exception. Return unused. 0.2 ECMAScript function objects. ECMAScript funct. On objects encapsulate parameterized ECMAScript code closed over a lexical environment and support the dynamic evaluation of that code. An ECMAScript function object is an ordinary object and has the same internal slots and the same internal methods as other ordinary objects. The code of an ECMAScript function object may be either strict mode code, 1122, or non-strict code. An ECMAScript function object whose code is strict mode code is called a strict function. One whose code is not strict mode code is called a non-strict function. In addition to and, ECMAScript function objects also have the internal slots listed in Table 30. Table 30. Internal slots of ECMAScript function objects. Internal slot. Type. Description. Environment. An environment record. The environment record that the function was closed over. Used as the outer environment when evaluating the code of the function. Private environment. A. Private environment record or null. The private environment record for private names that the function was closed over null if this function is not syntactically.
I think I finally separated files. I gotta include the new files I made, paste these into those, and then run it. It's taking so long.
Not the function is a derived class.
I just gotta go through and replace int with a new keyword for whatever generates the stuff, whatever I gotta find properties and stuff.
Function was created. This mode, lexical, strict.
Almost done.
To this value of a lexically enclosing function. Strict.
This really couldn't be more boring. This is so boring. I actually want to get decoding anything other than this. Just formatting and making files and shuffling stuff around. It's so boring.
Table 30. Internal slots of ECMAScript function objects. Continued. Internal slot. Type. Description. Strict. A boolean. True if this is a strict function. False if this is a non-strict function. Home object. An object. If the function uses super. This is the object whose provides the object where super property lookups begin. Source text. A sequence of Unicode code points. The source text that defines the function. Fields. A list of class field definition records. If the function is a class. This is a list of records representing the non-static fields and corresponding initializers of the class. Private methods. A list of private elements. If the function is a class. This is a list representing the non-static private methods and accessors of the class. Class field initializer name. A string. A symbol. A private name. Or empty. If the function is created as the initializer of a class field. The name to use for named evaluation of the field. Empty otherwise is class constructor. A boolean indicates whether the function is a class constructor. If true, invoking the functions will immediately throw a type error exception. All ECMAScript function objects have the internal method defined here. ECMAScript functions that are also constructors in addition have the internal method 0, 2, 1. This arguments list. The internal method of an ECMAScript function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values. and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. Let callee context be prepare for ordinary call. F. Undefined. Assert. Callee context is now the running execution context. If F is true, then a let error be a newly created type error object. B note. Error is created in callee context with F's associated realm record. C. Remove callee context from the execution context stack and restore caller context as the running execution context. D. Return throw completion. Error. Perform ordinary call bind this. F. Callee context. This argument. Let result be completion. Ordinary call evaluate body. F. Arguments list. Remove callee context from the execution context stack and restore caller context as the running execution context. If result is a return completion, return result. Return of abrupt. Result 0. Return undefined.
haven't been distracted in a while, so I'm gonna get distracted. I got a, I don't know, an old Apple keyboard or whatever, like the really old one. Typing on the wrong keyboard, that's great. God, 2011? Is that 14 years old? Right? I'm pretty sure it's 14. I don't know. Just double check. It's old. You still have Apple USB wired keyboards, whatever, from 2011 on Amazon, like refurbished, whatever. I got I think it's this one. Sure, it's this one. It's not the same. I hate it. It kills me to type on it. So I got this, whatever, because I got this, and I think Windows broke it. Windows did something to it that doesn't work. And Windows is doing it to this other keyboard I have. I don't know. Something about USB-C in the keyboard and Bluetooth, and Windows is like screwing stuff up. So like I had a keyboard like this and it's not working. It might, I don't know. So instead of buying another one, I got this one or whatever. I hope it's not yellow. It's probably gonna look all yellow. So I got this instead. $51 is a rip-off for an 11-year-old, 14-year-old keyboard. That's refurbished. That's some bullshit. But whatever. It's like 51. That's bullshit. How can they sell for 51? I don't care. I'm hoping it's not gonna be all yellowed. I just realized the keyboard's probably gonna look yellow. I hope the key doesn't look like that when I get it. I don't know if this guy broke the keyboard on purpose after buying it. What kind of hammer is that? It's not a hammer. What the heck is that blue thing? I don't know. It might be a rip-off keyboard. I probably just wasted $50. I don't want to buy this again because it's probably going to break. I think it has like USB 2.0 on the side of it. I don't know. It's probably going to be a broken keyboard. It's going to be all yellowed because it's like 14 years old. This probably wasn't the best idea. I'm done being distracted. I'm just kind of disappointed now. I'm gonna keep programming. Hopefully, the keyboard's not complete crap. It probably will be. But even if it is crap, as long as it works, it's better than this knockoff Mac brand I have. I don't know. I need to focus. And the sound's not working.
code. Early errors prevent attempting to assign to this binding, so its mutability is not observable. Else, I perform env create mutable binding, arguments, false. Perform env initialize binding, arguments, f let parameter bind parameter names and arguments. 3. Else, let parameter bindings be parameter names. 4. Let iterator record be create list iterator record.
So I don't know. Hopefully that 14-year-old keyboard works, and it's probably not gonna work. It's probably a waste of money.
Iterator record.
I'm going to compare these outputs against the old outputs, include them in the project. And try to run it. If it's good, and it runs, and it's done, or whatever, this part's done.
Env create mutable binding, n, false. Perform env initialize binding.
Then it can finally get on to 64-bit arithmetic or whatever. And actually, I'm still like rewriting code from 32-bit to 64-bit, but at least I'm not replacing a keyword for a type name, because that sucks. And I still have to I still have to update this, what it's generating, to get rid of the int. I guess I'll do that first. And then I'll get the 64-bit arithmetic. This is also boring. It's like really boring. This is like the most tedious, boring thing ever. Really boring. I need to focus, so I'm gonna try to do that.
R with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note, an xb 3, 2, 1 adds additional steps at this point. 0. If strict is false, then a let lexi-env be new declarative environment. Vari-env, be note, non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexical scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexi-env be vari-env. 2. Set the lexical environment of callee context to lexi-env. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element D of lex declarations, do a note.
I hate the word print. I call a variable print underscore A. This is going to print underscore B. This prints underscore. It's not even the print call. I'm just using the word print all over the place to tag things that log to the console or are printed to the screen. And everything is freaking named print. I'm trying to find int, and everything is named print. So I have to click through a whole bunch of freaking non-int matches. I need to like use a different word for print, like log or something from now on. Stop using the word print for anything, because it's so frustrating. Half the file is the word print. I need to like use the word log from now on. This would be my new thing. Use the word log. I can't use print anymore ever again. This is ridiculous to like sort through. Okay, I'm gonna shut up, and this sucks. This really sucks. I'm so freaking bored.
unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1.0.3.1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1.0.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024. 1.0.3.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Return, built-in call or construct, f. This arguments list, undefined 1.0.3.2, arguments list, new target. The internal method O, f a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Return, built-in call or construct, f, uninitialized, arguments list, new target 1.0.3.3 built-in call or construct, f. This arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value, or uninitialized. Arguments list, a list of ECMAScript language values, and new target. A constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended.
So I gotta replace int here, whatever, this.
To f. Let callee realm be f. Set the realm of callee.
And then it looks like I have another file with a whole bunch of these. I have to go like this. I don't know. It's a lot easier than doing the C program. And it just prints whatever to these stupid files.
Specification of f if this argument is uninitialized.
Over here. I just gotta get through this and then I'm done with this stuff. And then there's more stuff. At least this stuff will be done. So boring.
The behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024 185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the current realm record. If prototype is not present, set prototype to realm. Let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let fun be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set fun to prototype, set fun to true, set fun to realm, set fun to null, 0. Perform set function length, func, length, 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0.4 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMAScript function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to and Table 31, internal slots of bound function exotic objects. Internal slot type description bound target function a callable object the wrapped function object bound this an ECMAScript language value the value that is always passed as this value when calling the wrapped function bound arguments a list of ECMAScript language values a list of values whose elements are used as the first arguments to any call to the wrapped function 186 ECMA International 2024 10411 This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct. Target. Args. New target. 0, 4, 1, 3 bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMAScript language value. And bound args. A list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function, let internal slots list be the list concatenation of, and the internal slots listed in Table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj is described in 10411. If this constructor target function is true, then a set obj is described in 10412. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0 4 to array exotic objects. An array is an exotic object that gives special treatment to array index property keys. C6 1 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1. P, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index b 32 p g if index length and length desc is false return false h let succeeded b ordinary define known property a p desc I if succeeded is false return false j if index length then I set length desc to index plus 1 2 set succeeded to ordinary define known property a length desc 3 assert succeeded is true k return true return ordinary define known property a p desc 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define known property a length property descriptor length true false false return a 0 4 2 3 array species create original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array original array. If is array is false, return array create length. Let c be get original array constructor. If is constructor c is true, then 88. ECMA International 2024. A let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then, I have same value. C. Realm is true. Set C to undefined. If C is an object, then I set C to get C. Add at species. B. If C is null, set C to undefined. If C is undefined, return. Array create. Length. If this constructor, C, is false, throw a type error exception. Return. Construct. C. Length. 0, 4, 2. 4 array set length. A. Desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define known property A. Length. Desk. Let new len desk be a copy of desk. Let new len be. 32. Desk. Let number len be. To number. Desk. If same value 0, new len, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property A. Length. Assert. Is data descriptor. Old len desk. Is true. Assert. Old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define known property A. Length. New len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else. A note. Setting the attribute to false is deferred in case any elements cannot be deleted. B. Let new writable be false. C. Set new len desk to true. 5. Let succeeded be. Ordinary define known property A. Length. New len desk. 6. If succeeded is false, return false. 7. For each own property keep P of a such that P is an array index and 32. P. New len. In descending numeric index order. Do a let delete succeeded B. A. P. B. If delete succeeded is false, then I set new len desk to 32. P plus 1. 2. If new writable is false, set new len desk to false. 3. Perform. Ordinary define known property A. Length. New len desk. 5. Return false. 8. If new writable is false, then assert succeeded to. Ordinary define known property A. Length. Property descriptor. False. B. Assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor F, or a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply, a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have internal slot 1, 0, 4, 3, 1. P. The internal method of a string exotic object S takes argument P, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property S. P. If desk is not undefined, return desk. Return string get own property. S. P. 0, 4, 3, 2. P. Desk. The internal method of a string exotic object S takes arguments P, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property. S. P. If string desk is not undefined, then a let extensible be S. P. Return is compatible property descriptor, extensible, desk, string desk. Return ordinary define own property. S. P. Desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O. Assert str as a string. Let len be the length of str for each integer I such that 0 len. In ascending order, do a append to string I to keys for each own property key P of O such that P is an array index and to an integer or infinity P len. In ascending numeric index order, do a append P to keys for each own property key P of O such that P is a string and P is not an array index. In ascending chronological order of property creation, do a append P to keys. 90. ECMA International 2024. 8. For each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do a append P to keys. 9. Return keys 0, 4, 3, 4 string create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1. Set S as specified in 1, 0, 4, 3, 2. Set S as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw S length. Property descriptor length. False. Enumerable. False. False. Return S 0, 4, 3, 5 string get own property. S P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If P is not a string, return undefined. Let index be canonical numeric index string P. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be S. Assert str as a string. Let len be the length of str. If r, int x, 0 or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r, index +1, 1. Return the property descriptor. Result str. False. True. False. 0, 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is O, NLY used by object prototype to string 2, 0, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee, which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note 5. ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor. 0441p. The internal method of an argument's exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property, args p. If desk is undefined, return undefined. Let map be args. Let is mapped be has own property, map p. If is mapped is true, then a set desk to get map p6. Return desk 0442p. Desk. The internal method of an argument's exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args. Let is mapped be has own property, map p. Let new arg desk be desk. If is mapped is true and is data descriptor, desk is true. Then, if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map p. Let allowed be ordinary define own property, args p. New arg desk 92. ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor, desk, is true, then I perform map p. Be else if desk has a field, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p. Desk false 2. If desk has a field and desk is false, then perform map p8. Return true 0443. The let map be args. Let is mapped be has own property, map p. If is mapped is false, then a return ordinary get args p. Receiver 4. Else a assert map contains a formal parameter mapping for p. P return get map p. 0444. The if same value args receiver is false, then a let is mapped be false. Else a let map be args b. Let is mapped be has own property, map p. If is mapped is true, then a assert the the following set will succeed. Since formal parameters mapped by arguments objects are always writable. B perform. Set map p v false return. Ordinary set args p v receiver 0 4 4 5 p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args. Let is mapped be has own property map p. Let result be ordinary delete args p. If result is true and is mapped is true, then a perform map p5. Return result. ECMA International 2024 193 104446. Create and mapped arguments object arguments list. The abstract operation create and mapped arguments object takes argu meant arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create. Object prototype set obj to undefined. Perform. Define property or throw. Obj length. Property descriptor len. True enumerable. False. True. Let index be 0. Repeat. While index len a let val be arguments list. Index b perform. Create data property or throw obj to string index val c set index plus 1. Perform. Define property or throw obj at iterator property descriptor array prototype values true false true. Perform. Define property or throw obj callee property descriptor throw type error false false. Return obj 0 4 4 7. Create mapped arguments object func formals arguments list env. The abstract operation create mapped arguments object takes arguments func an object formals a parse node arguments list a list of ECMAScript language values, and env an environment record, and returns an argument's exotic object. It performs the following steps when called. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0 4 4 1. Set obj is specified in 1 0 4 4 2. Set obj is specified in 1 0 4 4 5. Set obj to object prototype 0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat. While index len a let val be arguments list. Index b perform. Create data property or throw obj to string index val c set index plus 1 6. Perform. Define property or throw obj length property descriptor len true false true 7. Let map names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0 94. ECMA International 2024 A B C. Let name be parameter names index. If map names does not contain name, then I append name to map names 2. If index len, then let g be make arg getter name env. Let p be make arg setter name env. Perform map to string index property descriptor at p get g false true. Set index 1 20. Perform. Define property or throw obj at iterator property descriptor array prototype values true false true 1. Perform. define property or throw, obj, callee, property descriptor, func, true, false, true 2. Return obj 0, 4, 4, 7, 1 make arg getter, name, env. The abstract operation make arg getter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value, name, false. Let getter be create built-in function, getClosure, 0. Note, getter is never directly accessible to ECMAScript code. Return getter, 0, 4, 4, 7, to make arg setter, name, env. The abstract operation make arg setter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called. A return env set mutable binding, name, value, false. Let setter be create built-in function, setClosure, 1. Note, setter is never directly accessible to ECMAScript code. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1, p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p be if numeric index is not undefined, then I let value be typed array get element. Oh, numeric index 2. If value is undefined, return undefined. 3. Return the property descriptor, value, true, able, true, true. Return ordinary get own property, O, P, ECMA International 2024 195, 10, 4, 5, 2, P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p be if numeric index is not undefined, return as valid integer index. O, numeric index, return. Ordinary has property O, p 0, 4, 5, 3, p, desk. The internal method of a typed array O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string, p be if numeric index is not undefined, then if is valid integer index. O, numeric index, is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If is access a descriptor, desk, is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element. Oh, numeric index, desk. 7. Return true. Return. Ordinary define own property. O, p, desk. 0, 4, 5, 4. The. If p is a string, then a let numeric index be canonical numeric index string, p be if numeric index is not undefined, then I return typed array get element. Oh, numeric index 2. Return. Ordinary get. O. P. Receiver 0, 4, 5, 5. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then I if same value O receiver is true, then perform typed array set element O numeric index V return true 2. If as valid integer index O numeric index is false, return true. Return ordinary set O P V receiver 96 ECMA International 2024 10456 P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P be if numeric index is not undefined, then I if as valid integer index O numeric index is false, return true, else return false 2. Return ordinary delete O P 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy st. Let keys be a new empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record be for each integer I such that 0 length in ascending order do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do A append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do A append P to keys 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9. Capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O B J order. The abstract operation capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S takes arguments obj, a typed array, and order, sexy st or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If is detached buffer is true, then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. else a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record, obj, byte length 0, 4, 5, 1 0 typed array create, prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let A be make basic object. Internal slots list. Set A as specified in 1 0, 4, 5, 1. Set A is specified in 1 0, 4, 5, 2. Set A is specified in 1 0, 4, 5, 3. Set A is specified in 1 0, 4, 5, 6. Set A is specified in 1 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1 1 typed array byte length. Tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1 2 typed array length. Tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert. Is typed array out of bounds. Tar record. Is false. Let O be tar record. If O is not auto, return O. Assert. Is fixed length array buffer. O. Is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length. Byte offset. Element size 0, 4, 5, 1 3 is typed array out of bounds. Tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer. O. Is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start be O. If O is auto, then a let byte offset end be buffer byte length. Else, a let element size be typed array element size. O. Be let byte offset end be byte offset start plus O element size. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. Note: 0 length typed arrays are not considered out of bounds. 0. Return false. 0, 4, 5, 1 4 is valid integer index. O. Index. The abstract operation is valid integer index takes argument so, a typed array, and index, a number, and returns a boolean. It performs the following steps when called. If is detached buffer, O, is true, return false. If is integral number, index, is false, return false. If index is -0, return false. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true, return false. Let length be typed array length, tar record. If R, index, 0 or R, index, length, return false. Return true. 0, 4, 5, 1 5 typed array get element. O. Index. The abstract operation typed array get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. If as valid integer index, O, int x, is false, return undefined. Let offset be O. Let element size be typed array element size. O. Let byte index in buffer be R. Int x. Element size plus offset. Let element type be typed array element type. O. Return get value from buffer. O. Byte index in buffer. Element type. True. Unordered. 0, 4, 5, 1 6 typed array set element. O. Int x. Value. The abstract operation typed array set element takes arguments O, a typed array, int x, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be. To bigint, value. Otherwise, let num value be. To number, value. If as valid integer index, O, int x, is true, then a let offset be O, b let element size be typed array element size. O, c let byte index in buffer be R, int x, element size plus offset. D let element type be typed array element type. O, e perform set value in buffer. O, byte index in buffer, element type, num value. True, unordered, return unused. ECMA International 2024 199, 10, 4, 5, 1 7 is array buffer view out of bounds. O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexy S T B return is view out of bounds. View record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST return is typed array out of bounds. Tar record 0 4 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module. C16 2 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare f and 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V. 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary get. Own property O. P. Let exports be O. If exports does not contain P, return undefined. Let value be O. Return property descriptor. Value. True. True. False. 0 4 6 6. P. Desk. The internal method of a module namespace exotic object O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is access a descriptor, desk, is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk, current, return true. 0 4 6 7. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, return ordinary has property O. P. Let exports be O. If exports contains P, return true, return false. ECMA International 2024 201 1 0 4 6 8. The. If P is a symbol, then a return ordinary get O. P. Receiver. Let exports be O. If exports does not contain P, return undefined. Let M be O. Let binding be M resolve export. P. Assert. Binding is a resolved binding record. Let target module be binding. Assert. Target module is not undefined. If binding is namespace, then a return get module namespace. Target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value. Binding true 0 4 6 9. The return false 1 0 4 6 1 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If P is a symbol, then a return ordinary delete O. P. Let exports be O. If exports contains P, return false. Return true. 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pairs arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 1046 12 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let m be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 1046. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype sort % using undefined as compare fn. Set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O V10 4 7 to set immutable prototype O V. The abstract operation set immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. T current B. O. If same value, V, current, is true, return true. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. proxy handler methods. Internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property, descriptor, define own property, has, get, set, delete, property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariance defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object, P is a property key value, V is any ECMAScript language value, and desc is a property descriptor record. O for copyright sign, ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, get prototype of, if trap is undefined, then a return target, let handler proto be. Call, trap, handler, target, if handler proto is not an object and handler proto is not null, throw a type error exception, let extensible target be. Is extensible target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy, O, let target be O, let handler be O, assert. Handler is an object, let trap be. Get method, handler, set prototype of, if trap is undefined, then a return target. V, let boolean trap result be to boolean. Call, trap, handler, target, V, if boolean trap result is false, return false, let extensible target be. Is extensible target 0. If extensible target is true, return true 1. Let target proto be target 2. If same value, V, target proto, is false, throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. 3. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. Let target result be is extensible. Target. If boolean trap result is not target result, throw a type error exception 0. Return boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Prevent extensions. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. If boolean trap result is true, then a let extensible target be is extensible. Target be if extensible target is true. Throw a type error exception. Return boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note for proxy objects enforces the following invariants. The result of is a boolean value. Applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoke proxy O. Let target be O. 06. ECMA International 2024. 3. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get own property descriptor. If trap is undefined, then a return target. P. Let trap result OBJB. Call. Trap. Handler. Target. P. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. Let target desk be target, p. 0. If trap result obj is undefined, then A. If target desk is undefined, return undefined. B. If target desk is false, throw a type error exception. C. Let extensible target be is extensible. Target. D. If extensible target is false, throw a type error exception. E. Return undefined. 1. Let extensible target be is extensible. Target. 2. Let result desk be to property descriptor. Trap result obj. 3. Perform complete property descriptor. Result desk. 4. Let valid be as compatible property descriptor. Extensible target. Result desk. Target desk. 5. If valid is false, throw a type error exception. 6. If result desk is false, then if target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field. 2. If target desk is true, throw a type error exception. 7. Return result desk. Note for proxy objects enforces the following invariants. The result of must be either an object or undefined. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of a non-extensible target object. A property cannot be reported as existent if it does not exist as an own property of the target object and the target object is not extensible. A property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object. A property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p. Desk. The internal method of a proxy exotic object O takes arguments P, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Define property. If trap is undefined, then a return target. P. Desc. Let desc obj be from property descriptor. Desc. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. Desc obj. If boolean trap result is false, return false. 0. Let target desc be target. P. ECMA International 2024 207. 11. Let extensible target be. Is extensible. Target. 2. If desc has a field and desc is false, then a let setting config false be true. 13. Else a let setting config false be false. 4. If target desc is undefined, then if extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 5. Else if is compatible property descriptor, extensible target, desc, target desc, is false, throw a type error exception. B. If setting config false is true and target desc is true, throw a type error exception. C. If is data descriptor, target desc, is true, target desc is false, and target desc is true, then I. If desc has a field and desc is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be added. If the target object is not extensible, a property cannot be non-configurable, unless there exists a corresponding non-configurable own property of the target object. A non-configurable property cannot be non-writable, unless there exists a corresponding non-configurable, non-writable own property of the target object. If a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler has. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, then a let target desc be target. P. B. If target desc is not undefined, then I. If target desc is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. Return boolean trap result. 08. ECMA International 2024. Note for proxy objects enforces the following invariance. The result of is a boolean value. A property cannot be reported as non-existent if it exists as a non-configurable own property of the target object. A property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The perform. Validate non-revoke pros I, O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get. If trap is undefined, then a return target. Let trap result be. Call. Trap. Handler. Target. P. Receiver. Let target desc be target. P. If target desc is not undefined and target desc is false, then if is data descriptor, target desc, is true and target desc is false, then I. If same value, trap result, target desc, is false, throw a type error exception. B. If is accessor descriptor, target desc, is true and target desc. 0. Return trap result. Note. The value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-writable Non-configurable own data property. The value reported for a property must be undefined if the corresponding target object property is an unconfigurable own accessor property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. V. Receiver. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk, is true and target desk is false, then I if same value, V, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true, then I if target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false, throw a type error exception. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a boolean value. A property cannot be reported as deleted if it exists as a non-configurable own property of the target object. A property cannot be reported.
I finally replaced all of the ints. Now I'm going to build it, or run it, whatever. If it doesn't work, I'm going to explode with just out of like sheer anger and frustration, because that took forever. I thought it'd be easier, but no. Another thing about that was auto-generated. I don't know why I call these auto-generated files. I literally just put everything in JavaScript to like make data blobs, and I output them. It's all like typed by hand. Nothing's automated. So I'm gonna run it. I'm hoping it's gonna work.
Throw a type error option. Label target.
Instead of hope, it's gonna work. I'm just gonna like it has to work. Here we go.
Assert. Target keys contains no duplicate entries. 4. Let target configurable keys be in empty list.
I think it worked.
Empty list.
I don't really want to investigate if it did work. I'm gonna BRB, then I'll figure that out. For now, I think it worked. At least there's no warnings.
Configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked result keys does not contain key, throw a type E raw exception. B remove key from unchecked result keys. 0. If extensible target is true, Return trap result 1. For each element key of target configurable keys, do if unchecked result keys does not contain key, throw a type error exception, be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list. The returned list contains no duplicate entries. The type of each result list element is either string or symbol. The result list must contain the keys of all non-configurable own properties of the target object. If the target object is not extensible, then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. Let argArray be create array from list. Arguments list. Return. Call. Trap. Handler. Target. This argument. argArray. Note a proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. ECMA International 2024 211. The 10th of May 2013. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Assert. Is constructor. Target. Is true. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Construct. If trap is undefined, then a return. Construct. Target. Arguments list. New target. Let argArray be create array from list. Arguments list. Let new obj be. Call. Trap. Handler. Target. argArray. New target. 0. If new obj is not an object, throw a type error exception. 1. Return new obj. Note 2 for proxy objects enforces the following invariance. The result of must be an object. 0. 5. 1 for validate non-revoke proxy. Proxy. The abstract operation validate non-revoke proxy takes argument proxy, a prox, y exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let P be make basic object. Set P's essential internal methods, except friend, to the definitions specified in 10.5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. Set P to target, set P to handler, return P. 12. ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation processes the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write N instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics, UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0XFF, return the string value consisting of the code unit whose numeric value is CP. Let CP1 be the code unit whose numeric value is floor. CP0 times 10,000. 0 times 400 plus 0 XD800. Let Q2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 XDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1 3 static semantics, UTF-16 surrogate pair to code point, led, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments led a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Led is a leading surrogate and trail is a trailing surrogate. Let CP be led 0 XD800. 0 times 400 plus trail 0 XDC00 plus 0 times 10,000. Return the code point CP. 1 4 static semantics. Code point at string position. The abstract operation code pointer takes argument string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6.1.4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when call ed. Let size be the length of string. Assert position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then return the record CP 1 full 6. If a first is a trailing surrogate or position plus 1 equals size, then return the record CP 1 true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then return the record CP 1 true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6.1.4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position size. Let CP be code point at string position be append CP to code points. Set position to position plus CP. Return code points. 14. ECMA International 2024. 1.1.1. 6 static semantics. Parse text. Source text. Goal symbol. The abstract operation parse text takes argument source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is passed as part of a function declaration, function expression, generator declaration, generator expression, async, C function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is passed to supply the value of the and internal slots, C10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is passed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters an async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors parse might report the syntax error and not proceed to the early errors parse. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor, 202.1.1, the generator function constructor, 273.1.1, and the async function constructor, 277.1.1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1. 2. 1 directive prologues and the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1. 2. Strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4. 3. 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, or async arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive. Function code that is supplied as the arguments to the built-in function, generator, async function. and async generator constructors is strict mode code if the last argument is a string that, when processed, is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign. ECMA International 2024. Note the expression statements of a directive prologue evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use-strict directive and which occur in a directive prologue. If an appropriate notification mechanism exists, an implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use-strict directive and which does not have a meaning defined by the implementation. 1. 2. 3. Non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element #bang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 12.10, in examples such as the following: a equals b high g exec, CMAP, D, where the first non-white space, non-comment code point after a line terminator is u plus 002f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as a equals b high g exec, CMAP, D. Syntax. Input element div, white space, line terminator comment token div punctuator, right brace punctuator. Input element regexp, white space, line terminator comment token right brace punctuator regular expression literal. ECMA International 2024 217. Capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space, line terminator comment token regular expression literal template substitution tail. Input element template tail, whitespace, line terminator comment token div punctuated template substitution tail, input element hashbang or regexp, whitespace, line terminator comment token hashbang comment regular expression literal. 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher-level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus F, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. ZWMBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMAScript source text, ZWMBSP, code points are treated as whitespace characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point name abbreviation usage U plus 200C 0 width non-joiner ZWNJ identifier part U plus 200D 0 width joiner ZWJ identifier part U plus FEF 0 width no break space ZWNBSP white space 218 ECMA International 2024 12.2 white space code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript whitespace code points are listed in Table 36. Table 36. Whitespace code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF. U plus FF. 0 width no break space. ZWNBSP. Any code point in general category space separator. USP. No 1 U plus 0020. Space. And U plus 00A0. No break space. Code points are part of USP syntax. Note 2. Other than for the code points listed in Table 36. ECMAScript whitespace intentionally excludes all code points that have the Unicode whitespace property but which are not classified in general category space separator. ZEDS. 2.3 Whitespace. Tab. VT. FF. ZWMBSP. USP. Line terminators. Like whitespace code points, line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike whitespace code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail, LF. MCR line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S-class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37. Line terminator code points. Code point. Unicode name. Abbreviation. U+000. Line feed. LF. U+000D. Carriage return CR. U+2028. Line separator. LS. U+2029. Paragraph separator. PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence, CR, LF, is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax, line terminator, LF, CRLS, PS, line terminator sequence, LF, CR look ahead, LF. LS, PS, CRLF. 2.4 comments. Comments can be either single or multi-line. Multi-line comments cannot nest, because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and BICO as part of the stream of input elements for the syntactic grammar. This point is very important because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax. Comment. Multi-line comment. Single line comment. 20. ECMA International 2024. Multi-line comment. Multi-line comment charsopt. Multi-line comment chars. Multi-line not asterisk char. Multi-line comment charsopt. Post asterisk comment charsopt. Post asterisk comment chars. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R D. Capital S L A S H. Capital O R. Capital A S T E. Multi-line comment charsopt. Post asterisk comment charsopt. Multi-line not asterisk char. Source character but not. Capital M U L T I. Capital L I N E. Capital N O T. Capital F O R W A R D. Capital S L A S H. Capital O R. Capital A S T E. Source character but not one of all. Single line comment. Single line comment charsopt. Single line comment chars. Single line comment char. Single line comment charsopt. Single line comment char. Source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and like other types of comments are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single line comment charsopt. 2.6 tokens. Syntax. Common token. Identifier name. Private identifier punctuator. Numeric literal string literal template. Note the div punctuator. Regular expression literal. Right brace punctuator. And template substitution tail productions derive additional tokens that are not included in the common token production. ECMA International 2024-221. 12.7 Names and keywords. Identifier name and reserved word are tokens that are interpreted according to the default identifier syntax given in Unicode Standard Annex number 31, identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name. The syntactic grammar defines identifier as an identifier name that is not a reserved word. The Unicode identifier grammar is based on character properties specified by the Unicode standard. The Unicode code points and the specified categories in the latest version of the Unicode standard must be treated as in those categories by all conforming ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier start, identifier name, identifier part, identifier start char, Unicode escape sequence, identifier part char, Unicode escape sequence, identifier start char, Unicode ID start, underscore, identifier part char, Unicode ID continue, ZWNJ, ZWJ, assign letter, one of a.
Grefgeikel not Christofixis ab Grefgeikel.
Not but Gustavwexes. Unicode ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequences given in 1.2.9.4. Note 1. This standard specifies specific code point additions, U+0024, $, and U+005F, low line, are permitted anywhere in an identifier name, and the code points U+200C, 0 width non-joiner, and U+200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name. 22. Copyright sign, ECMA International 2024. Note 2. The non-terminal identifier part derives via Unicode ID continue. 2. 7. 1. Identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid. In other words, if a Unicode escape sequence were replaced by the source character it contributes, the result must still be a valid identifier name that has the exact same sequence of source character elements as the original identifier name. All interpretations of identifier name within this specification are based upon their actual code points regardless of whether or not an escape sequence was used to contribute any particular code point. 2. Identifier names that are canonically equivalent according to the Unicode standard and not equal unless, after replacement of each Unicode escape sequence, they are represented by the exact same sequence of code points. 2. 7. 1. 1. Static semantics. Early errors. Identifier start. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier start char lexical grammar production. Identifier part. Unicode escape sequence. It is a syntax error if identifier code point of Unicode escape sequence is not some Unicode code point matched by the identifier part char lexical grammar production. 2. 7. 1. 2. Static semantics. Identifier code points. The syntax-directed operation identifier code points takes no arguments and returns a list of code points. It is defined piecewise over the following productions. Identifier name. Identifier start. Let CP be identifier code point of identifier start. Return CP. Identifier name. Identifier name. Identifier part. Let CPS be identifier code points of the derived identifier name. Let CP be identifier code point of identifier part. Return the list concatenation of CPS and CP. 2. 7. 1. 3. Static semantics. Identifier code point. The syntax-directed operation identifier code point takes no arguments and returns a code point. It is defined piecewise over the following productions. Identifier start, identifier start char, return the code point matched by identifier start char. Note 3. The sets of code points with Unicode properties ID start and ID continue include, respectively, the code points with Unicode properties other ID start and other ID continue. ECMA International 2024 223. Identifier part. Identifier part char. Return the code point matched by identifier part char. Unicode escape sequence. U hex 4 digits. Return the code point whose numeric value is the NV of hex 4 digits. Unicode escape sequence. U code point. Return the code point whose numeric value is the NV of code point. 2, 7. 2 keywords and reserved words. A keyword is a token that matches identifier name, but also has a syntactic use. That is, it appears literally, in a fixed-width font, in some syntactic production. The keywords of ECMAScript include if, while, async, await, and many others. A reserved word is an identifier name that cannot be used as an identifier. Many keywords are reserved words, but some are not, and some are reserved only in certain contexts if and while a reserved word's await is reserved only inside async functions and modules async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in the reserved word list below, except for await and yield, are unconditionally reserved. Exceptions for await and yield are specified in 13.1, using parameterized syntactic productions. Lastly, several early error rules restrict the set of valid identifiers. C13, 1, 1, 1, 4, 3, 1, 1, 1, 4, 7, 5, 1, and 1, 5, 7, 1. In summary, there are 5 categories of identifier names: those that are always allowed as identifiers, and are not keywords, such as math, window, to string, and those that are never allowed as identifiers, namely the reserved words listed below except await and yield. Those that are contextually allowed as identifiers, namely await and yield. Those that are contextually disallowed as identifiers, in strict mode code. Let, static, implements, interface, package, private, protected, and public. Those that are always allowed as identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax: reserved word. 1 of await break case catch class const continue debugger default delete 2 else enum export extends false finally for function of import and instantia of new null return super switch this throw true try type off var void well with a yield 24 ECMA International 2024 Note 1 per 5, 1.5 Keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public are future reserved words in strict mode code. Note 3 the names arguments and eval are not keywords, but they are subject to some restrictions in strict mode code. C13, 1, 1, 8, 6, 4, 1, 5, 2, 1, 1, 5, 5, 1, 1, 5, 6, 1, and 1, 5, 8, 1. 2.8 Punctuators syntax. Punctuator. Optional chaining punctuator. Other punctuator. Optional chaining punctuator. Look ahead decimal digit. Other punctuator. 1 of, comma equals, equals 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 plus, percent plus plus, and equals plus equals 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 percent equals 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 and equals 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 and equals 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 equals. Div punctuator equals sign. Right brace punctuator 2.9 literals 2, 9, 1 null literals syntax. Null literal Null. ECMA International 2024 225. 1 2 9. 2 Boolean literals syntax. Boolean literal. True, false. 2 9. 3 numeric literals syntax. Numeric literal separator. Numeric literal. Decimal literal. Decimal big integer literal non-decimal integer literal. Plus sep. Non-decimal integer literal. Plus sep. Begin literal suffix legacy octal integer literal. Decimal big integer literal. 0 big int literal suffix. Non-zero digit decimal digits. Plus sep oct begin literal suffix. Non-zero digit numeric literal separator decimal digits. Plus sep. Begin literal suffix. Non-decimal integer literal. Sep. Binary integer literal sep. Octal integer literal sep. Hex integer literal sep. Begin literal suffix. N. Decimal literal. Decimal integer literal. Decimal digits. Plus sep opt exponent part. Plus sep opt. Decimal digits. Plus sep. Exponent part. Plus sep opt. Decimal integer literal exponent part. Plus sep opt. Decimal integer literal. 0 non-zero digit. Non-zero digit numeric literal separator opt decimal digits. Plus sep. Non-octal decimal integer literal. Decimal digits. Sep. Decimal digit. Decimal digits sep. Decimal digit. Plus sep. Decimal digits. Plus sep. Numeric literal separator decimal digit. Decimal digit. 1 of 0 1 2 3 4 5 6 7 8 9. 26. ECMA International 2024.
I'm pretty sure that I got all this replaced. I'm gonna like include the new files, whatever, and then I'll cut the chunk that is being replaced now. Paste it, wrap it in like an if 0, so like one enter, the preprocessor, it's 0, and then I'll run the new code and build it, and if it builds, it should be fine. I don't think I missed any. I think I should got them all. I'm finding replacing. I still have a couple macros to check. So do this first, and then I'll leave those other macros for later. I'm gonna like get started on the address arithmetic. What's this? Is BRB? Dang it! This keyboard's not working. This keyboard sucks because it's not. Now it's working. Now it's clicking and doesn't say BRB. I'll just repeat whatever I said. I'm pretty sure I got everything replaced. So I'm like include a new file. I'm gonna like wrap the old code that's being replaced. Wrap it in a preprocessor is 0, so it's omitted. And then run the new code. And I'm pretty sure I got everything replaced. If not, it'd be like really obvious and it wouldn't build. So I'm gonna do that. I'll get back to the macros that aren't resolved yet. Do this later. And I can finally, well, after I do like the couple things I just said, I gotta save it back up to, and then I finally be to converting the 32-bit address arithmetic to 64-bit address arithmetic. It's like 4 or 5 days to this maybe. Then a lot of stuff, but then it's like actually writing new code. Maybe 4 or 5 days of converting it, and then like 2-3 days of checking it. It's gonna take a week. I'm just gonna like get the new stuff included and try to build it, save it back up, and that's like progress, whatever. Anything's progress, it's just so boring. I hate updating old code. It sucks. I'm gonna drink some water and whatever. It's taking so long to do. The address arithmetic is gonna suck. There's so many macros. I'm just gonna get started on it in a second and not think ahead, because then I won't want to do it. This is so boring. Okay, now it's including the generated, or the auto-generated, not really auto-generated. This is all basically typed by hand. Nothing's really auto-generated. Anyways, I'm really hoping this is gonna build. Please just build. Please. I don't want to deal with bugs. Just work. Please work. Oh, this compiler's so slow. I hate this compiler. I think something's wrong with it. So I'll just undo and try that again. The one file's not even included. I had to convert it anyways, just in case it's needed. And the other file, I think there's something wrong with it. So building again. This is like with it off. I gotta turn it back on and then figure out whatever's messed up with the file. This takes so long to build. At least the old build still works. So I'll run it, save it back up, and try to fix whatever this is. That's probably all I'm going to get done. I don't even want to do address arithmetic now. This is getting old. At least I got this done. Well, this isn't done yet until it builds. At least I possibly almost got this done. This part of it. Replacing the cast type word, whatever. This is close. I don't think I'm gonna be able to get it fixed in like a short amount of time. I literally put a check in all the spots in JavaScript that makes the code output to check for an int or an int pointer. And there was no int, and there's no int pointers. So I must have messed something up when renaming. And I formed the name of something that isn't existent. Everything else looks okay. Save it back up. If I don't get this done, like now, whatever, it's probably gonna take up 2 hours tomorrow. But then I can do the address arithmetic when the stuff's out of the way. I'm probably gonna sleep like a baby, because I feel like I accomplished something. I still have like the whole standard to complete, but I got the type names in, so the whole standard, I don't know, I got something done, at least. Something's done out of all of it. Or like, not done yet, technically, because there's a bug, but close enough to done. Yeah, no, it's not done till it's done, it's not done. There's a whole lot of these to go through. Like a whole lot. There's a 3,254 keyword message for the type. Oh, dang it. I think I'm done for now. This is gonna be a big annoying thing to tweak or adjust. Okay, so this is like the token whatever here. And then here I'm gluing function string. Let's say it's a function, whatever, it's a string. Like obviously. And then here I glue this token with this token with the keyword type. So there's a whole concat tokenization gluing what you call it, naming convention going on here. And the problem is right here. In JavaScript, I have this whatever is the type. Here, and then it gets glued to this token system or naming convention. So like this one is the same token as this one. But for some reason won't highlight. There it goes. The only difference is that this is glued to the front of it. This is the prototype macro of this token. This is a function macro of this token. So I take this token, I can glue it to this token, and then to get the prototype, the function, or to get the argv, whatever I want, I glue that beginning of whatever this is. There's a whole like naming thing going on, and it has to follow that rule or whatever convention. I don't know. Call it. But then here, the rest of the code is calling these things, and it expects int. But since I renamed it to the new type name, which is this is not int. This is IJTSC capital lowercase t underscore lowercase q underscore underscore, which is not int. So all the functions that take this is like the function whatever that I call behind the scenes. It's gluing this. I think I have like the return type or something. I don't know. Something like this, whatever. Let's do that. It does something, whatever. So behind the scenes, it's gonna take this and glue a string to it. function. And then it's going to glue this token. And then I'll glue int. And since all the other places are still using int, it means that this is not int. Obviously not int. So when it glues to call this, it doesn't exist. This has the wrong name, and it's named like this. But it needs to be this type here instead of int. So tomorrow I have to make a little lookup table, do like a lookup table, and do like type, and then like I don't know, native. So I have to make some kind of like lookup or whatever. So wherever in the file it's gluing the token. All the places where it needs the keyword, like actually this keyword, I'll use the type, whatever property to get the type. So if I get the type, this is here. And that property of whatever this thing is. It would glue this, which is an int, because it's the wrong name, so everything expects int to be int. But I do need the new value, so only where it's gluing tokens is where I needed to like not use the actual name and use the old name. Otherwise I gotta update every single place that calls these macros. That'll take insanely long to do. Like insanely long to do. There's no way I'm gonna bother to do that for it, like right now. Maybe I could like split it up over a couple days. I still don't want to do that. I'm just gonna leave it as in. Anyways, if I were to like glue this instead, get the native key here, and instead of returning this, to be glued here, like that. This is for JavaScript, whatever, not C. Then instead it would take int, let's use native, and when it glues it like this, now it's the right type. The int named function, in all places where it needs to actually be this text literally. I'll do like this and then dot native or braces, doesn't matter. So I'm done for now. It's gonna take a couple hours to go through and update the JavaScript to output the correct code. Not that it's incorrect, it's just not putting the right word. So I guess it's incorrect, but it's not a problem because I know that it's not a problem because I know what the issue is and not. So I don't know. Next stream I'm gonna go through and I guess make another variant of this type. I think I called like the const or something in front. I'll like leave that as it is and make a new type called I'll just call it I don't give a fuck. So this type can be the name itself, whatever. The string, textual, whatever you call it, identifier. So that way all the old stuff stays as it is. All the new stuff I'll figure out an actual name. Other than that, tomorrow. Everything using this though will need to be accessed with the extra property. Accessed between, I don't know, I'm gonna come up with no names. These are just like, it's put them together as an example. So when using this type, whatever, here, const, I have to use a picket property access, and I'll either return this, do like type maybe, or it'll return int. And I'll pass in this around whatever as like the argument when it defines things. So it'll be like, it'll have a, I don't know, the property is tagged present or whatever to get it as the actual name or as a native type int. This is so boring. So I don't know. I'm probably gonna have to do this solution tomorrow. Or I can make like a global array. And then it doesn't matter what I do. I'll do something tomorrow. For now though, I'm done. I saved it back up, I think. Pretty sure I saved it back up. So I'm gonna like, yeah, I did. So I'm gonna like sit down and then I'll torture myself some more, converting the rest of this tomorrow. I'm tortured out today with finding and replacing. So until next stream, peace. I'm gonna let the stream run on for like 10 more minutes because it doesn't always end. So if I let it go on for 10 more minutes, it might send the whole stream. So I'm not gonna BRB, this is actually the end or whatever. Peace. The mouse is not working. Until tomorrow. It's always tomorrow. Until it's not. Where's the freaking thing? There it is. Oh, Siri wasn't reading. Dang it.
Three numeric literals syntax. Numeric literal separator. Numeric literal. Decimal literal. Decimal big integer literal non-decimal integer literal. Plus sep. Non-decimal integer literal. Plus sep. Begin literal suffix legacy octal integer literal. Decimal big integer literal. Zero big int literal suffix. Non-zero digit decimal digits. Plus sep opt begin literal suffix. Non-zero digit numeric literal separator decimal digits. Plus sep. Begin literal suffix. Non-decimal integer literal. Sep. Binary integer literal sep. Octal integer literal sep. Hex integer literal sep. Begin literal suffix. N. Decimal literal. Decimal integer literal. Decimal digits. Plus sep opt exponent part. Plus sep opt. Decimal digits. Plus sep. Exponent part. Plus sep opt. Decimal integer literal exponent part. Plus sep opt. Decimal integer literal. 0 non-zero digit. Non-zero digit numeric literal separator opt decimal digits. Plus sep. Non-octal decimal integer literal. Decimal digits. Sep. Decimal digit. Decimal digit sep. Decimal digit. Plus sep. Decimal digits. Plus sep. Numeric literal separator decimal digit. Decimal digit. 1 of 0 1 2 3 4 5 6 7 8 9 26. ECMA International 2024. Non-zero digit. 1 of 123,456,789. Exponent part. Sep. Exponent indicator signed integer sep. Exponent indicator. 1 of EE. Signed integer. Sep. Decimal digit sep. Decimal digit sep. Decimal digit sep. Binary integer literal. Sep. 0b binary digit sep. 0b binary digit sep. Binary digits. Sep. Binary digit. Binary digit sep. Binary digit. Plus sep. Binary digits. Plus sep. Numeric literal separator binary digit. Binary digit. 1 of 0 1. Octal integer literal. Sep. 0 octal digit sep. 0 octal digit sep. Octal digits. Sep. Octal digit. Octal digit sep. Octal digit. Plus sep. Octal digits. Plus sep. Numeric literal separator octal digit. Legacy octal integer literal. 0 octal digit. Legacy octal integer literal octal digit. Non-octal decimal integer literal. 0 non-octal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Non-octal digit non-octal decimal integer literal decimal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. 0 octal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, SEP, 0x hex digits SEP, 0x hex digits SEP, hex digits, SEP, hex digit SEP, hex digit, plus SEP, hex digits, plus SEP, numeric literal separator hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef ABCDEF. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal integer literal decimal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy 2, 9, 3, 2 static semantics, MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal plus T, the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal. 10e, where e is the MV of exponent part, the MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator and e is the MV of exponent part, the MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part, the MV of decimal literal. Decimal integer literal exponent part is the MV of decimal integer literal 10e, where e is the MV of exponent part, the MV of decimal integer literal. 0 is 0, the MV of decimal integer literal. Non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal digits. Decimal digits decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, the MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, the MV of exponent part. Exponent indicator signed integer is the MV of signed integer, the MV of signed integer. Decimal digits is the negative of the MV of decimal digits, the MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0, the MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the MV of decimal digit. 2 or of non-zero digit, the MV of decimal digit. 3 or of non-zero digit, the MV of decimal digit. 4 or of non-zero digit, the MV of decimal digit. 5 or of non-zero digit, the MV of decimal digit. 6 or of non-zero digit, the MV of decimal digit. 7 or of non-zero digit, the MV of decimal digit. 8 or of non-zero digit, the MV of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hexed digit. 7 or of octal digit. 7 is 7.